Imagine a landscape where lichens are not just tiny patches on rocks and branches, but vibrant characters in a complex ecological story. In this episode of Geographical Thinking, we'll talk with Miranda Frison, a master's student looking to uncover the hidden intricacies of lichen communities through ecological modeling. Welcome back to Geographical Thinking. I'm Michelle Brake, and I'll be your guide as we explore ideas, stories, and conversations through the lens of geography. Joining me today is Miranda, a second-year student in the Masters of Art in Geography program at St. Mary's University in Halifax, Nova Scotia, where she delves into the intricate world of lichens, particularly focusing on three threatened species found in Atlantic Canada: the eastern waterfan, wrinkled shingle, and black foam lichen. Her research involves employing geomatics to model potential habitats and estimate population sizes. Miranda's academic journey includes a certificate and specialization in organic agriculture from Dalhousie University, a Bachelor of Science with a major in biology and minor in English from Dalhousie University, a graduate certificate in GIS from the Center of Geographic Sciences. Miranda is committed to the advancement of geomatics and serves on the board of directors for the Geomatics Association of Nova Scotia, GANS, and contributes to teaching as a teaching assistant with various GIS courses as well. Welcome, Miranda, and thank you for joining me today on Geographical Thinking.
Thank you for having me, Michelle. I'm really excited to be able to chat more about my research with you today.
Yeah, I'm looking forward to it. And we have some interesting lichens: waterfan, wrinkled shingle. I did not know there were such funky names.
They're all very unique. The one that I'm focusing more on right now is the eastern waterfan lichen, which is actually found in streams, compared to the other two, the wrinkled shingle and the black foam, which are actually found on trees. And most people don't think that lichens are actually found in streams, and I didn't know that myself until I got into this research. A lot of people don't even know what lichens are. So my little easy way to explain what they are is, you see those leafy things growing on the sides of trees? Those are lichens. Because a lot of people, they know what that word is, they know what they're seeing, but they just don't know the combination between the two.
Yeah, and that makes sense for trees. Now, when we're talking about streams, are we looking at rocks? Are they growing on the sides of a fish? What am I looking for?
No, the eastern waterfan grows on rocks. That'd be kind of funny to see it on a fish, though. But yeah, no, this one is found in shallow streams in Atlantic Canada. So if you're walking downstream, you might see this little leafy looking thing growing on a stream, or usually a darkish brown green kind of color. And each lichen will also kind of change color depending on if it has moisture on it. So you might see a huge change in various lichen species, because they might go from being a brownish color to, then if they get some moisture on them, they might turn a bright green. So it's kind of interesting, because it can make your life a little bit more difficult if you're not used to seeing it in one color versus another color.
Yeah, that sounds like you really have to keep your eyes peeled. Now, that's some great introduction, but let's take it back. Can you tell us more about your research and what exactly with lichen are you studying?
What I'm doing is I'm not doing any field work myself. I have some people who are going to go test my models in the field themselves. But what I'm doing is I'm working primarily with ArcGIS Pro and a software called Maxent. And I am getting into working with some R coding as well. So I have gathered resources online and from literature, and my research partner, ACCDC, the Atlantic Canada Conservation Data Center. They're my industry partner through my tax. And what I'm doing is I'm combining all of my data into my study area, which is Quebec, Eastern Quebec, Nova Scotia, PI, New Brunswick, and Newfoundland. It's quite a large study area to be working with, to be fair.
I'd say so.
Yeah. And one of the big challenges with working with such a huge study area I've been finding is, one, getting the data for every province, and also making sure that's standardized, to make sure that it's easy to run it through my Maxent software, because you need to make sure your rasters are all the same cell size. So that's been one of the hurdles. I've created some data myself too. And then I've also collected the presence. I'm looking at presence only data. So where we are aware of where eastern water fan is located. And I have about just over 900 um, instances of them being located. But that's not all at once. That's over a couple decades worth of collection. And then I have a bias file too. So that's basically what we use like search tracks. So where we know that we've collected and using that within the model so that it's able to take account if we have like a higher concentration that we're looking at in within the study area, like say like a researcher's walking around doing field work and we're finding a lot of the lichen in one location versus another location, it's helping the model find a balance between that. It helps it with like the processing of it, so like it helps it for weighting.
Interesting. And that does sound like a lot to
Mm-hmm.
fine tune over time. How does
It is.
the modeling process go then with such complex ideas and habitats and various factors?
Mm-hmm.
What does it reveal about lichen?
Yeah. So I'm using Maxent and I am using a DM. I had one of my collections of variables was from a website called Climate North America, and so that provided me using the I put my DM into it and some parameters, and it's able to provide me with the various climate variables for my study area. And in general, after I've collected all of my variables that I've decided based off of the ecological requirements for the species that I'm aware of, after doing literature search, I am going and backwards selecting my my variables based off of their importance to the model. So what's interesting is with Climate North America is it is taking me a little bit longer because I am doing it step by step, removing say like 45 variables down to just a handful, under 10 variables of the ones that are best producing suitable habitat. It is giving me the opportunity to really get a better understanding of what the variables are doing, and it's a great learning opportunity so that when it comes time for when I'm making my models for my other two species, my wrinkled shingle and my black foam lichen, I have a better understanding of what's going on behind the scenes. Because once I'm complete with my model, my plan is to use our coding so that I can do most of it behind the scenes without me having to handhold Maxent. And that will speed up my process for finding the correct model. And just going to circle back to the Maxent side of it is once I have the Maxent completed for my Eastern water fan, I'm able to use that almost like an answer key for my R software. So with going off of that, I can use our libraries to create a replicated model of what I've created with Maxent and have Maxent be like my answer key to know that I'm doing the right thing, right process for our with my R coding, and then just use R coding for my other two lichens.
Gotcha. Okay, so you're breaking down, going from so many variables, a world of variables potentially, into that smaller subset of the 40 down to 10,
Mm-hmm.
using those elevation models, narrowing it down. Where could these be found? And you said that you're using this to then help set up further software for your other two species. Is that going to go a machine learning area where it's going to do some of the work and then you're going to check its work? Or will it still be more of that manual process?
It's a little bit of both. So my goal is to have the our software to do most of the legwork for me. And so that will save me potentially hours or days of time of going through and setting up Maxent for each run that I do, because each run is considered like taking away one more variable. And so sometimes you can get up to 60 plus runs and each of them take hours to run. So yeah, that could take a while. So my plan is to use R to do most of the legwork leading up to when I get down to probably around 10 variables. And then I'll be doing it manually from there on out. So right now I'm at about 4 variables for my Eastern water fan model, and it's looking pretty good from here on out. So I'm hoping that this one's the final model for that one.
Okay, and looking at the Eastern water fan, and you have
Mhm.
these four variables. What kind of variables are we talking? Is this like the right temperature or the sun shines in this direction?
Yeah, it's. I can actually tell you which ones I have. I I think I'm allowed to tell. I haven't have it published yet. That's the thing. So I'll keep it generalized then. Um, but one of I've been trying to keep it into account the ecological realism of the species. So that's based off of past literature, connecting with research experts, and consultation with my supervisors, Dr. Peter Bush and Dr. Sean Hoyen. And so my 4 variables, one of them is Acer saccharum, so that's a sugar maple, which is pretty interesting for having that in there. It's been in the literature. It's the lichen has been regularly found in areas with sugar maple. Um, and then my other variables are relating to water, which is not uncommon because I mean we're finding this lichen in the water. And then my other variables are relating more to words like precipitation and temperature, which also makes sense for this lichen too, because it needs the stream to be a certain temperature in order for it to thrive.
It's interesting to hear that the presence of the sugar maple of like one specific tree could be a potential factor. And hearing your study areas of Quebec, parts of Eastern Canada, and it being a common tree that comes up within Indigenous stories within our areas, as well as part of the Acadian forest that does make up a large portion of our areas. I can see how that would connect some of the dots together. And that's really interesting to hear how something that I've heard about in other areas could be a big factor here.
Exactly. Yes, and it wasn't like I had just put in only this tree into my model too. There is a dozen or so different trees, and we are looking at like the more dominant tree species within the areas. And so going back to like where I had gotten the data for like knowing where these trees were located, I some of the places I had downloaded my data was from like the Climate North America, the Canada National Geographic Hydrographic Network, Global Forest Watch to understand like if there was a tree loss in an area over another, and Geogratis was another one,
Nice. That's great to see.
and that's just some
Yeah.
of them. But that's like that comes into play with like we're having to standardize everything because you are getting data from so many different places, trying to find that standardization and finding the right projection for such a large study area as well too. So my resolution is 250-meter resolution, and there may or may not have been a change in what my results are if I changed my cell size. And that's something that I'm interested in exploring down the road if I have time in my thesis, is to choose maybe one province compared to all of those provinces and play around with the cell size to see if my model is still predicting the same suitable habitats versus if it was 250 meters.
hmm And I think that's interesting to hear of how much back and forth there is within a research process. I think being out in the world, we sometimes forget how much you need to double check, triple check, verify, work with different cell sizes. Once we're out of school, it's the, oh, well, I don't test as many things maybe anymore. I don't play around with hex bin sizes or what are my resolutions or, hey, let's go with a province to province to check variables. We work within our location or our job parameters. So it's interesting to hear how much that goes into your thought process.
Exactly. And it's been very nice because I do have like 2 supervisors, and to have that conversation because when I was doing my studies at COGS, we did primarily focus on just one study area. We did talk about our projections and making sure that we're taking that into account. But for practicality wise, like this has been a really good learning experience and a good way for me to understand what's going on in the model and make sure that nothing is being skewed or limiting what skewness is going on with my model, so that I can address it. And if there are things that I can't address, at least I'm aware of it. I can make a note of it in my thesis that, hey, take this into account.
Gotcha. Now, lichen being such not a niche topic because it is everywhere, as we've discussed, but kind of more not the largest thing in the botanical garden. How did you get into choosing to study lichen and their ecological significance?
It was kind of funny how it came to be because what happened was I did a seaside course when I was at Dalhousie. So those are courses where you're doing a condensed course load over a course of 2 to 3 weeks in the summertime, and you get the chance to do field work for a lot of them. And so I took one course. This was before COVID. It was called Flora of Nova Scotia. And it was actually taught by the past botany curator at the Museum of Natural History. I was like, and so I contacted them. I was like, how can I get involved in getting some more hands-on stuff with learning more about botany? I was already kind of getting the idea that I wanted to do something like that for my career. And so I reached out to them, and the professor was like, hey, look, I used to be the botany curator. Why don't you reach out to the new one, and you might be able to help out with the herbarium? So I did. And that ended up being Dr. Sean Hoyen, who is one of my supervisors. And so I got some practice, like learning on some projects. We did some field work a couple summers ago looking at canopy lichens. And so I got some practice doing some field work, more of understanding how to the classification of the landscape and identifying the herbaceous material that is growing there. And there was like 9 different things that I was doing in each study site. It was like 3 trees a day that we were looking at Eastern Hemlock throughout Nova Scotia. Lots of fun. I did not do the climbing aspect of it. There was stuff looking at the base of the tree and stuff looking at climbing the tree, and no upper body strength. That is not for me. But the views are
Yeah,
great.
and you're telling me that like rock climbing and tree climbing aren't part of this wonderful extra program you've added on? I would have thought.
For some people, but yeah, my physical body, no, couldn't do it. But it was a really fun experience other than that. Um, so that is currently in the process of getting published. So I can't talk about that too much, but that's exciting. I'll when it does get published, it's in review. I'm the 3rd author, I believe, for that one. So that would be my first publication. That's really exciting. And then during COVID, I did an online course for like an introduction to GIS, and that was again through Dalhousie. And that one was taught when he was the lab supervisor for that one was Dr. Peter Bush. And so I faced some challenges of understanding like how to everybody was like learning how to learn online. That was the first time that a lot of course has been taught like that. And even though I was still kind of struggling on understanding how to get my computer to run the GIS because we were using like a virtual machine for that, I realized that it was a great opportunity to combine my interests in basically like understanding puzzles, like how everything connects, being able to add that element of visualization and communicating to other people, which kind of dives into my biology and English background as well. I was like, oh, this is like a mosaic. It's beautiful. It's like a little bit of everything. So I was finishing up my undergrad and decided that I was like, oh, I can go to COGS. COGS can let me be able to explore this further. It was a 1-year program. And towards the end of my program, I reached out to both Sean and Peter. I was like, I'd like to continue doing this. Would we be able to work together on a project? And so I'm continuing that project that I had started towards the end of my COGS degree. I was doing an experiential learning course, kind of starting the little bits and pieces of this Eastern water fan model, and then now tacking on the additional 2 lichens as well, the wrinkled shingle and black foam. So it's a little bit roundabout, but it's just like one of those things where it kind of all comes together. And I'm very happy that I am in this program and plan on using GIS and ecology down the road in my career.
No, that's exciting to see kind of where the threads of your story have taken you and how everything kind of builds on
That's a
each
good way
other.
of putting it.
Yeah, the threads of our story. The It's always interesting to hear what people's journey into GIS is, because you get people that kind of stumble into it within their career. It's an add-on versus where you've now intentionally brought it in. Great. So, looking beyond the modeling and the work that you're currently doing, what comes next? Will you have a chance to go out and ground truth some of your predictions with your modeling?
I won't be doing field work exactly for my research, but what the plan is field validation is very important for doing this sort of modeling. So when I've created the models, what it does is it gives me a range of 0 to 1, 0 being not suitable habitat and 1 being highest possible suitable habitat. And it, and so what I'm going to be doing is predicting where we think suitable habitat is, but also being conservative of our locations as well. We don't want to have a model that over predicts an area, which is why that element of ecological realism comes into play, of understanding the habitat and based off of past literature and consulting with research experts comes into play to understand how, when I'm reading the outputs of my models, if it's relevant for my species and if it's overestimating or underestimating. Because what my plan is to complete a model for each species and then have people from our and the Atlantic Canada Conservation Data Center, my industry partner, and potentially some outside people as well, to go and do some field validation to see if my model is predicting high suitable areas in areas that are actually finding these lichens versus areas that are not suitable. So I'd love to be able to have someone go out there and test areas that we don't think is suitable, kind of suitable, and high suitable. The simplified terms of it.
Yes, but it's great to see that there's life beyond one program, one master's, because I know there's always so much more that can be built, and how research and even the GIS community, how we're constantly building on each other's work and it's influencing each other. So it's nice to see that there is life beyond just what we start to create.
Exactly. And there's so many different types of models that are out there too. And we, like with my supervisors and myself, we were talking about the ones that are most common for doing research like this, and Maxent ended up being one that was that made the most sense for me to do. And one of the reasons for that is because of the type of data that I have, where I have presence only data, and so there's like different requirements for each type of modeling. So like if you do like a generalized linear model, like a GLM or Mars, there's dozens of them out there, and Maxent was also one of the ones that I'm seeing more commonly used, but there are other reasons involved as to why this one was chosen over others. And the nice thing too is I can use a lot of this within R as well too, with just the different libraries.
It's great to hear that you're able to pull in your models and they work across multiple platforms, from starting at and using ArcGIS Pro, going over to Max Extent using R, that there's many software compatibility across the spectrum of things is great to see.
Exactly. Yeah, and like even down the road, perhaps I could even do all of it into Pro, because I know that since I've started this project, there's been new updates available where there is Maxent now in there, and I can do R in there. So it's nice to know that the software is developing and it could streamline it, because I'm taking the time to learn how to do it outside of the software. So maybe the next person will be able to do all in one place, and maybe their life will be a little bit easier, or maybe it'll be easier for them to make, say, a model builder and have it run everything for them. That'd be a really cool thing. But one thing that I've been really enjoying this is I've noticed that there's a huge community for people who are doing ecological modeling of not just like plants but bigger creatures, moose, deer, that sort of thing from all over the world. That's been really a great opportunity. I've been able to go and meet some of those people. There was a, a best practices meeting with other modelers so we can communicate to one another last January from Dalhousie, where we were meeting and discussing what would be the most important information for people who are just starting out modeling, what would be helpful for them to know. Because there's a lot of things that you kind of just learn but not putting onto paper. And access to open data, or if it isn't open data, how can you contact people to get access to data? Like, where do you start? And being able to meet modelers from around the world too has been a great opportunity. Had the chance to be able to go in September to Leipzig, Germany, to do a presentation on some of my preliminary research, and that was amazing. And getting to see the other softwares that are out there, the results, and giving me some ideas of how I can present my research to the public when I'm towards the end of my degree, which will be hopefully this time next year. Because I'd love to be able to create a publication, some posters, some oral presentations, and be able to communicate what I'm learning to the general public and to other scientists as well too.
Yeah, we'll have to stay tuned for all of that. And hopefully, maybe we'll see something in a story map competition or some of our map contests or the Esri Canada Scholars. We've got many options where hopefully we'll keep eyes for Miranda.
I would love that.
So would I. And thank you, Miranda, for joining me today. I hope you enjoyed yourself.
I likened working with you today. I had to.
Gotta get the lichen jokes in there. Thank you, Miranda. So, as we wrap up this wild ride through the wondrous world of lichen ecology, thank you, Miranda, for leading us on this adventure into the hidden intricacies of lichen communities. Who knew that these tiny patches on rocks and branches were the stars of their own ecological saga? If you're looking for more information on the technical side of GIS, check out Spatial Report, the podcast where Mark and Maggie dive into the latest and greatest in the world of GIS. Until next time, keep exploring, keep learning, and keep thinking geographically.